so this one says, find the sum of the following. And we've done the sum of all of these arithmetic sequences before, but I wanted to show you one with radicals. It's kind of like a preamble to what you're going to be getting into. Now, you can add radical functions that have like radicands. So whatever is underneath your radical sign, if it's the same, you can add them. It's just like as if it was 2x plus 3x. You can add those because they both have x, right? But if it was 2x plus 3y, you couldn't add them, correct? So if this was root 2, root 3, you could put the first two together, but you wouldn't be able to add the third one because they're not like terms, okay? That's basically all you need to know about radicals. You treat the square root 2 for now like as if it was like an x, let's say, okay? So they want the sum of the following. So we know the first term, we know the last term, we know the difference, even though you might not believe me. What are we missing in order to find a sum? N. We always need n. So let's figure out what we have here. So we have T1 is negative 13 root 2. Tn is 27 root 2. D is second term minus first term. So negative 9 root 2 minus negative 13 root 2. Because remember, we just minus whatever it is, and it's negative. Now, minusing a minus is like what? Adding. So this is actually like negative 9 root 2 plus 13 root 2, which was what? 4 root 2, exactly. So that's my difference. I still need to use the Tn formula to get n though, right? Because I can't find it sum, whether it's the short formula or the long formula, if I don't know n. So we're going to go Tn equals T1 plus n minus 1d. Bless you. Now make sure you have some paper out, a pencil out, something out you should be writing. All right. So Tn is 27 root 2. T1 is negative 13 root 2. Plus n we don't know. And d is 4 root 2. Now if you add 13 root 2 to both sides, you're going to get 40 root 2 equals n minus 1 times 4 root 2. The next thing we always do is we divide by the d, and the d in this case is 4 root 2. If we treat that root 2 just like it's an x, what if I had this? If I had 40x divided by 4x, what would you tell me it is? 10, right? It's the same thing here. 40 root 2 divided by 4 root 2 is 10. The root 2's cancel, and 40 divided by 4 is 10, just like x's would be. And we add our 1, and n equals 11. Now we know n, we know T1, and we know Tn. So we can find the sum with the short formula, right? So we're going to do S11 equals 11 divided by 2. T1, which was negative 13 root 2, plus Tn, which was 27 root 2. So it's going to be 5.5. Negative 13 plus 27 is what? Now, when you multiply radicals, you multiply the coefficients together and the radicals together. Well, there's only one radical. So my answer is going to be square root 2. And then I just multiply those coefficients. So what's 5.5 times 14? 5.5 times 14. 77. Thank you. So the sum of the first 11 terms is 77 root 2, which is going to make sense. You're going to have that root 2 because every single time you add them, you just keep the root 2 because it's common, right? Then you just add the coefficients. Then I wouldn't be able to, if it's not common, I'm not going to ask a question like that right now because it'd be so far past you. So if it was root 2, root 3, root 2, root 3, you could add all the root 3s and you could add all the root 2s. So it would be just like having 3x plus 4y plus something x plus something y. You could combine the y's and you could combine the x's. Root 2 plus something square root 3. Yeah, yeah, exactly. So this is a more advanced question that we're just showing you how you could build into this when we get to other units. Okay? So let's go to geometric. So you don't have to write these all down. I'm just showing you an example. If you want to just even do one example, you can. But geometric sequences are a sequence of numbers where the ratio r, common ratio, can multiply or divide between the terms. So we've used d up until now, and it's a common difference. It's what you add, you go up by, or what you subtract, what you go down by, right? That was d. Well, geometric actually goes up by multiplication or division. So that would be like 2, 4, 8, 16 if I was multiplying by 2, right? Or it could be 16, 8, 4 dividing by 2, okay? But our common ratio is always what we multiply by. So if we're dividing by 2, my common ratio isn't going to be divided by 2. What's another way of saying for multiplying if you're dividing by 2? You're multiplying by 1/2. Okay? So if you're dividing by 2, your common ratio would actually be 1/2. If you were dividing by 5, your common ratio would be 1/5. Okay? Because your common ratio is always what you multiply to get to the next term. So this is the formula we're going to use. So now you have two TN formulas. So the very first thing you're going to have to figure out first off is this geometric or is this arithmetic? If it's arithmetic, I use the TN equals T1 plus N minus 1D formula. If it's geometric, if it goes up by multiplication, then I'm going to use this formula. Tn is still Tn, it's the last term. T1 is still the first term. N is still the number of terms. The difference is this R here. It's a common ratio. Do you know how we did the common difference was term 2 minus term 1, right? The common ratio is going to be term 2 divided by term 1. Okay? Could we use term 100 and divide it by term 99? Yes. Remember how when we did the common difference, you could take any term after and minus the term before it, and you got the common difference, correct? Same thing with ratio. You can take the term after it and divide it by the previous term, and you'll always get the common ratio. So you could do term 100 divided by term 99, and you would still get the common ratio. Okay? So it doesn't have to specifically be term 2, term 1. All right. Which of these are geometric? So what we're going to do is you're going to do term 2 divided by term 1, term 3 divided by term 2. If they're the same, it's geometric. If they're not, it's not. So term 2 divided by term 1. So 4 divided by 2 is 2. So you could do the next one, or you could literally just check them and see if it works, right? 2 times 2 is 4. 4 times 2 is 8. Is this geometric? No. What is this one actually? Arithmetic. So now here we go, term 2 divided by term 1. Instead of subtraction, you divide them for geometric. So 8 divided by 4, which is 2. Then we check them out. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So we're good, right? Geometric. This one doesn't have a common ratio, actually. Try C and D. So we'll try these out. This one's going to be R equals negative 15 divided by 5, which equals negative 3. 5 times negative 3 is negative 15. 15 times negative 3 is positive 45, so that's good. Division of fractions. When you do division of fractions, never put one on top of the other. That's kind of weird, and it's really hard to do fractions that way. So what we're going to do is we're going to do term 2. If we did it like this, divide by term 1, that's really hard to do fractions that way, actually. Fractions are meant to do division side by side. So what you would do is go 2 divided by 3. Wow, that was hard. Divided by 1/3. Now, what do you remember about fractions? You remember when you divide them, what do you have to do? You have to switch them and multiply. So invert and multiply. So 2/3 times 3/1. That's why this one's better if you write fractions side by side. They're set up to be done side by side. So you have to flip that second fraction. Not the first one, but the second one. And then when you multiply straight across. The only time you cross multiply is across an equal sign. So don't try and cross multiply here. So you're going to go 2 times 3, which is 6, and then 3 times 1, which is 3. 6 divided by 3 is 2. Now let's check for right. So 1/3 times 2, so times 2/1, would be 2/3. Okay, we got there. Then 2/3 times 2. See if we get the next one. Is 4/3. Is that the next one? No. So it's not. Make sense?